Oh, you can. Yeah. Oh,
All right, we good?
can you hear him? Is it? Can you try speaking?
Yes. Can
Okay.
you hear?
Yeah.
Awesome. Welcome everybody to the Westwood SolidWorks user group workshop on specifically how to take the CSWA test and some strategies on doing so. If you haven't done so already, which I mean, we had the QR code up for a couple minutes, but sign in. We'll have this when you CAD some of the parts, possibly later, and so eventually we'll get this again. But should I just get the answer? We'll give this to you eventually. So who we are? Is this yours?
This is working. Okay. So, this is actually our first workshop this quarter. It's actually our first workshop when we're branded as the Westwood SolidWorks user group. So SolidWorks user group in short is SWUG. And what we are is we're a UCLA student-run and student-oriented official SolidWorks user group. So we're part of an international network of, a couple hundred user groups spread across 6 continents, many, many countries. And our mission specifically is to communicate information about everything related to SolidWorks, so that's certifications, events within this user group network, networking events, and also just generally to promote future development into design and engineering. And as part of this goal, to further this goal, we work closely with UCLA student organizations. I'm pretty sure most of you were referred by a student organization here, and also UCLA engineering departments, mainly just for publicity, to provide a centralized location for CAD education. So, if you guys haven't already, please join the Discord. Does anybody? Everyone's on. Good. So the game plan for today. Actually, I skipped introductions, didn't I? Okay, that's a good idea. So I'm Abraham. Oh. Okay. So I'm Abraham. I'm one of the co-presidents. I'm a third-year mechanical engineering major.
I'm Colin. I'm a second-year aerospace engineering major, and I'm a workshop leader.
Hi, I'm Suraj. I'm also one of the co-presidents of SWUG.
Hi, I'm Luke. I'm a first-year Mackie, and I'm a publicity director.
Hello, I'm Nathan. I'm first year Mackie, and I also and I help teach.
So okay, now introductions are really over. The rest of what we're going to be covering today is what is the CSWA, and why you should take it. The second part is pretty important. And we're going to be going over an example CSWA test. We're going to be covering two parts, one assembly, and also covering the initial portion of the test, which is the drawing identification. And we'll finish off with questions and giveaway. The materials aren't here yet, but they will be here by the end of the workshop. So what does CSWA stand for? It stands for Certified SolidWorks Associate. This is the first exam that you'll take, provided by SolidWorks, if you want to get a certification. And the upcoming tests after this, after the associate one, are the professional and the expert. And in order to advance to the professional, you only need the associate. In order to get the expert, you need both the associate and the professional, and you also need a couple of specialty exams. So specialty is sustainability, 3D printing. There's a bunch of different sheet metal. Yeah, there's a bunch of different specialty exams that you have to take in order to get the expert. It's a 3-hour exam. You need a 70% score, which is pretty low, and it can be finished in under 2 hours. So personally, I finished it in well less than under 2 hours. 3 hours is more like if you have problems with the exam, or if you just really need some more time on it. But if you have at least a couple years of SolidWorks experience or general familiarity with the interface, you should definitely be able to finish it in under 2 hours. There is no live proctor. It is administered via actually an app that's just on your computer. And the app gives you all the files that you need to complete the exams, to give you the drawing. You submit your answers through the app. And so, it's in this case, it's kind of an honor-based system that you're not just going to go on Google and look up the answers, but we'll prepare you so you don't have to do that. And it's strongly recommended to work on your local machine. So to have SOLIDWORKS installed on your local machine, because if you're working over remote desktop, there is always the possibility that your connection drops and then you lose your files. And so then you have to start all over again, which is not good. Also, just the latency for remote desktop is not that good to work with. So the topics covered on the CSWA, this is a non-exhaustive list. This is just kind of an overview of all the things you might see on the CSWA. So sketching, just basic, your entities, your tools and relations. Entities just refers to the things that you actually put in a sketch, like lines, rectangles, ellipses, etc. Tools, that can be stuff like power trim, sketch fillet, and then relations is, coincident, collinear, etc. Then your features, your regular features, boss and cut. And then I highlighted revolves, sweeps, and loss because these are features that normally you won't see very often, but they might be tested on the exam. So it's good to have practice in these. Fillets and chamfers, those are, finishing features. Patterning. Feature conditions, this relates back to boss and cut features. So if you want to only have a feature go out to a specific vertex or a surface or a plane, you would apply these feature conditions. Mass properties, this is only for in the part section. In the part section, this is only for determining the mass of your component given the material. And for the assembly section, for determining the center of mass of your assembly. Materials, just to assign a material to your part to arrive at a correct mass. Inserting components into an assembly and your mates. It does say standard mates, but one of the mates that you may see on the assembly portion is called a width mate. I believe we might cover this in our assembly. But a width mate is just essentially where you have a wider dimension and you want to put something that's more narrow in the middle of it. So that's considered an advanced mate, but it might also be covered on the exam. Reference geometry and drawing interpretation. So in the next few slides, we'll go over drawing interpretation. Actually, sorry. First, why should you take the CSWA? Well, of 3 million registered users, so there's likely many more, who pirate it or who use a single license. Only 10% have the CSWA, 3% have the CSWP and the CSWA, and 0.1% have the CSWA with all of the previous certifications. So automatically, once you take a 3-hour exam, you're already better than, more than 90% of SOLIDWORKS users. So this is, yeah. And also, because it's a standardized exam, so everyone takes the same exam, this shows a standard level of proficiency that's better than just saying, I have X number of years in SOLIDWORKS and some projects, without, the recruiter or the person who you're talking to really knowing how much experience you actually have. And because there's no expiration date to your certificate, it has a very high benefit to cost. So most certifications normally expire, so you can't put them on your resume anymore after, say 5 years. But this certification will never expire. So we'll just go over some elements of drawings first. I'm pretty sure. Yeah.
I was gonna get a small little poll. How long have you guys been doing SolidWorks? Just probably since the start of college, maybe. Nice. Okay, that was me too last year. What clubs are you guys in? Yes. The same stuff. Okay. And then how much SolidWorks kind of have you? I know that's a broad question, but like is this stuff familiar? It's like making drawings out of the parts. And at any point during the workshop, if you're like, oh, we already know this, I mean, you can speak up because we only have 4 of you guys today, so this is very catered towards whatever you guys want out of this. We're here to help you. But also if you need us to slow down because maybe we did something too fast, also let us know. But, yeah.
So actually, on that note, can you guys identify generally what's on these drawings? What you would call the sheet of a drawing? What this thing is here? No? Yes? No? Okay, it's okay. I'll just quickly cover it. So this overall, the entire drawing, the background of the drawing is called a sheet, and these come in certain standardized sizes, based on certain international standards. This is called your title block, so it'll have information like your title, of the part. It'll have your revision. It'll have your mass, your material, the finishing, etc. So these are really useful if you're manufacturing or you're sending your drawing off to the manufacturer, so they know what material to use, they know what kind of finish to apply on the part, etc. Next, you have your standard isometric view, usually in the top right corner, and then you have what are called your projected views. So projected views are, as the name says, it's just basically a projection of a certain orthographic view onto the 2D surface. So on the left, you have your top view, then your front view, and then your right view. But what you also might see are, certain additional or more complicated views, like the section view. So I don't know if you guys can see, but there's a line here, blue dash line, that says A, and there's two arrows pointing up. So for a section view, at least, what this indicates is that you're taking, sorry, do you guys know? Do you guys already know what a section view is?
This appears quite often on a lot of practice questions.
Yeah,
So
you guys are
it's
good.
semi-important, but it's kind of self-explanatory.
Yeah. So it's basically you just take a piece of paper, you cut it, and then you're looking at it like this. So then you generate this view. And I think that's basically all. So this is the first part of the CSWA. They call it drafting competencies, but they just make it sound extra scary for I don't know whatever reason. It's really easy. It's just literally multiple choice. So I'll just step you guys through this first one, and then there's another one that I'll have you guys do. So the question is, to create drawing view B, it is necessary to sketch a spline. A spline is just basically a freeform sketch, as shown on drawing view A and insert which SolidWorks view type. So actually, just off the bat, which one do you guys think it is? In order to get to B from A. From A to from to B from A. Yeah, that's correct.
Yeah. Because the section view, as we saw before, it's like a single plane that will just cut through the part. And this is also just process elimination. Projected view is on a specific other plane, just coming from maybe an infinite distance far away. And then the isometric view is like the diagonal from all three of the three axes. So that's what the other ones do too. Oh, okay.
Yeah. So again, to arrive at B, what do you have to do to A? And sorry, the area of interest is in the top right corner of B.
It's kind of hard to see on
Yeah.
on here, but there's a kind of line that goes around here that outlines this section, but over here it's gray, so it's unfortunately hard to see on the projector.
Which one did you guys think it is? C? C? Yeah, that's correct. Broken out section. That's correct. Yeah, that's a good question. So a section view, you literally just take an entire plane, right? You take an infinite plane and you slice it. A broken out section allows you to see something that's inside of a part while also seeing the exterior. So in this case, the part is displayed as normal, but then only in the spline, within the spline that you sketch, you can see the inside. So that's kind of the difference.
It's in those instances where you want part of a section view, but it's good to see what fits in.
So, okay, this next section kind of is lead-in into our part creation section. So this is what you might see on the exam. The testing client is actually really badly made because it'll only show you, for example, this and then this on a completely separate view. So then you have to press your arrow key right, or you have to click a button in order to see the other ones. But for this, just for demonstration purposes, we just put this all on one slide. So when creating these parts from drawings, it's important to identify which sketch you're going to be making first, because that first sketch determines what you're going to do after that, right? If you make a very bad first sketch that doesn't get a lot of dimensions out of the way, then you might feel yourself down the road having to create a lot more unnecessary dimensions and having to actually calculate dimensions in the future. So as a rule of thumb, it's good to sketch the sketch or draw the sketch from the drawing view that has the most dimensions. So in this case, which one do you guys
I'm
feel
not gonna
like
lie, this is
the
one
most
of the
dimensions?
complicated parts.
Yeah. Which view do you guys see? Yeah, as the most dimensions. Yeah, exactly. So if you sketch this far left one, right, you get all of these dimensions out of the way, and then you can start looking at your other views, right? For example, if we started with, I don't know, this top view, first of all, it's hard to see what's going on here, right? Like, what is this? You're gonna have to look over here and be like, oh, that's actually, two surfaces. That's actually three surfaces, right? 1, 2, 3, all displayed as one. And then, maybe you would be inclined to also put these slots, etc. But yeah, it's that leftmost view is the correct one to sketch because it has the most dimension.
Awesome. And then so now we have a couple parts for you guys to try on your own, which you should have gotten in an email. Did you all receive the email? Nice. This is the document, right? You all have this first one?
Yeah. So we'll actually give you guys, this is a pretty simple, a good warm-up problem to start off with. So we'll give you guys 5 minutes to just do this on your own. We'll have a timer up here so you guys know how much 5 minutes is. If you guys finish faster than 5 minutes, just, raise your hand and then we can just proceed. Okay. Let me zoom in, sorry. Yep. How you guys feeling on time? No, lol. Do you guys need more time to finish? Do they need more time? Okay. Okay. 10 minutes? 10 minutes? Okay. 5 more minutes? 5 more, okay. Yeah. Colin, are we good? Yeah. Okay. I think we can just get started. So before we actually open up SolidWorks or tab over to SolidWorks, there's some important things that will always be present on the problem that they'll give you. And it's in the upper left-hand corner here. So this is what you really have to pay attention to, because if you get this wrong, then you'll get like completely different mass values. So first, on the left we see here unit system is IPS. So IPS is inch, pound, seconds, right? Then decimal place is 4. This is also important. You don't necessarily need to have this. Part origin arbitrary. This will almost always, I think, always be true for parts, because they don't ask you anything about center of mass. They only ask you for mass. Materials type plastics. Material is ABS plastic. And the density they give you is just for cross-checking. Because you're calculating mass, and mass is calculated in SolidWorks by calculating first the volume and then multiplying it by the density. So they just give it to you to check. And lastly, it says, hint, this part can be built using only 3 features. I don't think this will appear on the exam. But I mean, it's just, I don't know, it's just a good thing to work towards. But it doesn't necessarily, you don't necessarily need it. So with all that out of the way, let's go over to SolidWorks. Open up a part. And so the very first thing I'm going to do is close 3D Experience, and then change my unit system to IPS, and then open it. Then set my material, so ABS PC, and I'm just going to quickly check that I have the correct density for ABS PC. So it says, well, it's in the wrong unit. Yeah. Okay, so it matches, so that's good. So we know we have the right material. And so going back to what I said about the first sketching, the sketch with the most, with the most dimensions. So obviously it's this top right sketch here. And looking at the isometric view, you can see that this was made on the front plane. So you can just right click on the front plane, sketch it, and we want an ellipse to start. Ellipse. Center point, set the radius out. And then we see that 1.6 wide and 0.5 tall, 0.5 inches tall. Sorry, the shortcut that I just did was you hold right mouse and then you go up to get a smart dimensions, or of course you can always access it on the top side. 0.5 tall. 1.6 wide. And that's it for the ellipse. Next, we can just go ahead and tackle the center circle. So this circle. And this has a diameter of 0.45 inches. Oh. Okay. Yeah? Okay. Then we'll create the normal hexagon in the middle. With height of 0.23. And then lastly, create the 2 circles cut out on the side. ends are 0.125 in diameter. And okay, so now because it's fully black, we know it's fully defined, and we can go ahead and create our first boss. So extrude boss base, we want this profile, and this one, and actually this middle one. And it gives us a thickness of 0.15. What? Oops. No, it doesn't. That's our first, and then next we'll extrude. Actually, you're right. We should flip it. Yeah. Okay, the reason why I flipped it was just because we'll see in the next step. So the next step is for us to extrude this center profile here. Yeah, you're right. It has everything. Wait a second. I see. Let me just cut and offset it. Normally, I would just create the three sketches separately. No, okay. I think. Okay, so next is the extrude boss base for this one. And we go out and give a height of 0.45. And then last we finish up an extrude cut on the same step. And then do an offset of 0.1. And yeah, that's it. Okay. And then it doesn't look correct. Yeah. Okay. Sorry about that. Okay, I then doing it up. But anyway, so this is what you should end up with. And you can just go ahead and check the mass properties, and you get 0.01 pounds. Yeah. Really quick? Yeah? Okay. Okay, so that's the first part done. I'll now pass it over to Colin for the second part.
Any questions on that one?
Yeah. Good.
Awesome. And then the second part is this type thing. I guess we'll give you, what, 10 minutes to work on this, and then we'll go through it. And oh, actually, there's one important thing about this. Actually, can you guys just hear me? Oh, we have to record that. That's what I hear. The one important thing about this part specifically compared to the last one is that there's now variables. Have you all worked with those before? That's okay, because that's why we're here. So So I'm just gonna sketch on anything, honestly. Whatever. Am I on a sketch right now? Okay. Well, line. I'm gonna make a line. And then I'm gonna press. Here's a shortcut that I use, and that's using the S key. And that has a toolbar of whatever you can do. S key works on remote desktop because I use remote desktop, so I don't have a mouse usually. I just work on trackpad. And once you press the S key, you can right click and select customize. That allows you to customize whatever's on this toolbar. I have a whole list of stuff on here because I like the S key a lot. But with this, when you have the Smart Dimension tool pulled up, in order to set the length of it, you just click on it just as you normally do. Come on, what are you doing? Hello. And once you have that, it's going to prompt you to select or to type in how long it is. Instead of typing in a specific number, you can type in equals and then in quotation marks, whatever variable name you have. I'll show you how to make a variable name. This is just how you set that. So say I have a dimension of C, which I can show you how to define in a second. I do quotation mark C, and then this will create a new global variable named C, which that's just a variable. But how I would do it myself, there's in a little tab over here called equations. You can also search it up here, UQU. And at the very beginning of your part, what I would recommend is typing in all of these equations. So for example, right here, right here you have A is equal to 38, B is equal to 12, and C is equal to 3. So I would go C is equal to 3, A tab 38, and then B tab 12. And then now you have your global variables. Everyone following? Nice. And now, when you select, I'm going back into the sketch that I just made this line in. And see now C has changed dimensions because I changed the dimension in the equation. And quotation marks is just how you select a variable. So if you want to make it equal something, just set equal and then variable. So that should be what you need to know about those. Any questions on that? So the equations tab over here on the left is a little bit finicky because until you have an equation, I don't think it pops up. So I would just search up equations in here. Do you know what tab it's under here? It might be under evaluate sketch. Like equations. Okay, it's under the tools tab here. But yes, so once you have the equations, you can always right click equations and then manage equations, and it'll pop up your dimensions right here. So we'll give you 10 minutes for this drawing here, and we'll get back to you after that. All right. So there's still 40 seconds left. However, I will still start it early. This is, you can hear me? Cool. So, awesome. So, let me create a new file for the, or you know what? You know what? Let me get out of this. Should I just delete it? Yeah, I'll just delete it. Everything. Delete. 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 I'm just. What? That's a thing? So how do you do that? And then. Wait. Ah, okay. Whatever. I'll delete this. Okay, so now we're back at the start. Back at the start. Whatever. Okay, equations is gonna throw me some errors too, because I have these. Delete. Awesome. So 38, 12, and 3, which I believe are 38, 12, and 3. Okay. So first thing we're gonna do is start a sketch on. I like to go the top plane for this one. The top plane for this because the isometric view kind of gives it away, sort of. I think Abe referenced that before. But I'm just going to use the top plane for this. It's completely arbitrary and apart. But everything seems to be centered around this little circle thing in the middle. So I'm going to go create that real quickly. And the dimensions for the outside, according to down here, is 3 times A. So let me equal to 3 times A. And that will be, oh, you know what? It's millimeters. It's millimeters. There we go. And then this circle should be smaller. And I'm going to dimension that again. This, I believe, is equal to B. So I don't like how the mouse falls down. So equals B. And then everyone's following here. You all did this? Solid. Now, here's the fun part. I'm about to create a center line. And that didn't work, but we'll make it vertical because we can do that. You can also, when you're trying to set relations, you can also just right click and relations will pop up here as well. And it doesn't really matter where in the center line. In fact, I can even make it infinite, just handy dandy. And now I'm going to create another circle. So I use my S key a lot. And then create a couple more. Doesn't matter the size yet. And then go back to the Smart Dimension tool. How much is that? They're going to have 2/3 of a radius, or 2/3 of A for their inner radius, and then B for their outer radius. So, again, equals 2/3 times A. Nice. And now here's the fun part about the center line. Let me find the dimension first. So between the centers of the outer circles, I think you guys should all watch this because I don't think anyone uses center line. This is just a strategy of how you are going to make mirrored parts at some point. But this is 5 times A. So what I'm going to do here is I'm going to select the center and then click the center line. And it's going to treat it as if it has a mirrored part on the other side already. And that's the center line. So that's 5 times A. That seems about right. Now what's wrong with this? I can drag it around to see what's wrong. So see, now it's moving vertically. So I can select these two, right click, make horizontal. Now it's black and it's all tolerance. So I'm going to select L to make a line. Then just select these two. And then do this again. Then I'm going to select the line in the circle, make tangent. Line in the circle, make tangent. And then make all of these tangent. And eventually, this should be fully defined right here. Anyone have any questions about how I just did all that? And then to get all of these parts to the other side, I click mirror entities, which is just up here. I'm going to select both of these circles, both of these lines, and then I'm going to mirror it about this center line, which I drew earlier. Kablooey. Now I have it on both sides, and the dimensions line up because I use the center line as a reference point, or reference line feature, whatever. So now the first thing I'm going to do for 3D is figure out how tall I'm going to make basically just the center part. So that's going to be 25 plus 38. You can do that really easily by going to extruded, selecting just these two, and doing 25. Was it 25 plus 38? Yes, I have short-term memory. 25 plus 38. Now, if you do math, this is also one more thing that I think you guys should all look at. If you do math inside the box and you press enter, it's going to evaluate it and then set it to that. However, if you press the equal sign, equals 25 plus 38, it's going to set it equal to the result of that equation, 25 plus 38. So if you were to ever go back and add, maybe change 25 to 23, you can change it in the equation form. But when you don't have the equal sign, it just evaluates it and then sets it. Does that make sense? Nice, nice. So I like to have it equals to just in case I go back and change something. And then, so that's one. Oh, the material. I'm going to change it to poly to whatever. Okay. Oh. And now I'm going to extrude again. This time, when you press the extrude button, you can select a sketch that's already on like the screen, or if you go into the part tree, that's also an easy way to select the sketch. That's what I usually do. So now I'm going to extrude both of these. I know from before that these were just 25. Yes, 25 here. And that's the second extrude. So the third one is going to be down here. So I'm going to select this sketch once again, select this and that. And then according to the drawing, it's going to be 9 millimeters. So let me go like this. And then now I have this. Any questions? And now here's the fun part, because this this always trips me up. But I'm going to right click here, create a sketch that's on this face, because this is how I'm going to get that feature right here with all of the offset. So once I have the sketch, I'm going to select this face and press convert entities. And what that's going to do is basically project that face onto the sketch so that I have lines to work with here. Any questions about converting entities? So let me undo that quickly. So I have a face right here. What I want to do is I know that this line right here, this curvy line, is a thickness all around that little face in the middle of C. But currently on the sketch that I just made, I have nothing, like I don't know what to compare it to. C offset from where. So what I'm going to do is to get these lines onto the sketch, I click this face right here, which has the outline of what I want, and then click convert entities and see how these are black lines. Does that make sense? Okay. Awesome. And now I'm going to click offset entities. And this is the offset entities feature is a little weird because it doesn't let you do the equal sign. So I just set it to a default of like 1 millimeter. And then click this face. Maybe not that face. Hey, it did it for me. Not do that. Offset entities. And then I guess select here. And if you click select chain, I'm not sure why it doesn't do it. Okay, that's probably why. But I'm going to select all 4 of these, and then I'm going to reverse the direction so that it goes inside, and see how it offsets it fine. Because if you select this entire circle, because I know that see again. Okay, well I know that you were what was your name again? Ian, because Ian, I know you were trying to select the entire circle as something to offset. So what that does is that offsets the entire circle. But when you just have these lines right here, it just offsets those. So I'll just do like a sample one, because then when you have the dimension for the offset, that's when you can edit it to do equals C. Any questions on how to get that? And then the final step is just to fillet or fillet. I've heard many people refer to it as something different. If it gives you this error saying the resulting sections conflict, just make this smaller. Okay, maybe I'll go like 0.5 or whatever. Well, okay. Just in order to select all of these. And then I'm going to go back. And 8 times radius of C. So we go back to here. And this, I don't actually think will allow you to click an equals as well. So you're going to just click enter on any radius. Double click the dimension. And then set that equal to C as well. Any questions on that? All right, now we only have this on one side. So to get it on the other side, mirror entities, I'm going to just select everything. And then mirror about, you can also choose planes. So right now I'm going to mirror it across the right plane. And it's going to go onto the other side. Does that make sense? Awesome. And now I'm going to finally extrude this a distance of C. So equals, oh, the mouse didn't fall. Nice. Awesome. Any questions on how I did any of that? I included a lot of like different methods of, I guess, like doing center line stuff and offsetting. But now once you go to evaluate, this was D3. 315.86 grams. Currently it is not in document settings. Are you talking about right here? So, let me see if it says on the drawing, because unless otherwise stated, if there's a line that's going basically up to a circle, on SolidWorks, like the drawing, it's going to be tangent. Because that's really the only way you can modify that sketch to have it be constrained. I don't. That's not. I'm sorry. That's not a great answer. But, like, Abe, would you say it's just like assumed tangency if it appears so? Yeah, it's a little scuffed. I do agree. So any questions about any of that? It's okay if you do or don't. Bless you. Awesome. So now we have do something or no? It's not. Okay. So now in your emails, you all have a zip file or a folder with parts for the pliers, right? Awesome. Abe, do you want to real quickly put the parts in the assembly here and explain to them? Because I don't know which directory it's on in your computer. This is Abe's computer. Okay, so do you guys want me to run through how to do this assembly, or do you guys want to try it yourself? Oh, sounds good actually. Actually, I mean, I guess it's not big enough to open the part. That's all I was going to do at the beginning. So we'll give you 10 minutes for this as well. I think the mouse died. Ready, set, go. All right. So has anyone finished this? Oh, did you get it correct? Oh, sick. Nice, nice. But for the rest of you, I will be running through this. So let's go to here, file, new assembly. Now with assemblies, it's a lot more of like kind of follow the instructions like. So going back to here, download the zip file, save the parts, and create the assembly. The first step is inserting the handle base and then using the origin as the assembly origin. So here's handle base. And now once I have this, there's going to be several origins that I can pay attention to. This first one right here, that's going to be under the assembly or SM1 or whatever the assembly name is. That's the origin of the assembly itself. So all the parts that you put are going to be into the assembly file. That's the origin of that. And then underneath each part, you're going to have their own assembly, or their own origin. And right here, when I put the part in, I fixed it because SolidWorks does it automatically. So right click, select float, and then I should be able to move it around again. So now I'm going to click mate, and then select the origin of the assembly and the origin of the part. And they should both be lined up. So now, when I select out of mate, I try to move it, it's fully defined. Any questions on the origin for part versus assembly? Nice, nice. And then I'm going to insert the plier handle, because that's the next one. So insert components, plier handle. And you can use the browse button and insert components if the part's not open already in SolidWorks. So now they're mated concentric to plier joint. Plier joint is going to be the third one. So nice. That should be around here. So now I'm going to click mate, click the concentric, and then scroll in, click here. And now these two circles right here are concentric. It says concentric on the left as well. Any questions on concentricity or whatever? Which means they share the same center. Nice. And then second one, going to make this on here. And it's going to be on the other side, but when we made it, it should be able to flip. So I'll do that real quickly. I'm just following the instructions for right here. And then now, the plier handle base is, or end face, is coincident to the inside face. Actually, you know what? Let me just. Yeah, okay. So when I did the concentric earlier and it was concentric, I just basically flipped the alignment of that. That's what this means. But now this should, if I escape, this should be almost done. Nice. Now I go back. Plier handle base end face is coincident to inside face of plier joint, which is shown in detail C. So detail C right here. Click the key. Hold on. The end face. Does that just mean? Sorry, so the one I just did. The one I just. Oh, I see. Yeah. So now I'm going to mate it again, and it says no clearance. So the end face right here, I forgot about that, is going to be touching right here. There should be no clearance. And now the joint should not be able to be moved, except for rotating, because it's a rotating part. And then this also should be able to only be moved like this. now the interface are made at an angle A. So because it's an angle of a specific variable, I'm going to go into equations. No. And then A is 40 degrees. So I'm going to click tab, 40 degrees. Okay, you know what? There, 40 degrees. And when you name your variables, if you put in the unit as well, it also kind of helps you figure out which dimension is which, like 40 degrees versus 3 millimeters or something like that. Let's see. Now, once you have that, the interfaces of the plier handle are made at angle A. So, right here. So SolidWorks defaults to being coincident, just meaning that the planes are on top of each other. But I'm going to select the angle button right here and click 40. These options, so flip dimension means that the 40 degrees is going to be on the other side. And this is the orientation of how the parts are. So for example, on this face, the part is to the left of it. And on this face, the part is also going to be to the left of it. And it's going to align the same way. And then this aligns in the opposite orientation. So this makes the parts opposite 40 degrees, kind of. And now, everything should be fully defined. So if I try dragging the handle, fully defined, and this just rotates. So now, the center of mass is what we want to find. So we went to mass properties for the part, and that is exactly what we're going to do here. So when it needs to rebuild, and just let it rebuild. So now, let's see. Let's go down to, what was this? J1. Okay. J1. So right now it's in millimeters. Did I do this wrong, Abe? Did you get that as well? The what? Oh, ISO. Right. Wait, no, because that should have been, hold on. Was it? Because I used the origin as the assembly origin. Right, so so I'm going to go back to this edit feature. And then now what this is going to do, it's just going to spin around that basically. So because I want to align it so it looks like this, I'm going to select a plane from one of the parts and mate that to a plane that's connected to one of the, or just a plane in the assembly. So let me go to mate. So for this, I'll select the, let's see, let me get an isometric view kind of. Oh, that's not isometric. And then I'll select the front plane. And then let me go to the plier handle base. Make it front plane as well. And that should be coincident. And then I can just, is it like this what you have done, Dave? Or is this what you would have done? Well, it's not done yet. I'm just saying it. And then I was going to select the top plane. And click the top plane. That should do that. And that should give you all 3 degrees of freedom. but it's also fixed. Okay. So let me go back to the top page. However, I will edit the other one also. Okay, there's better work. Let's go to mass properties. It's still not it. Wait. That's so odd.